Hey everyone, and welcome back to the channel where we unravel the mysteries of the universe. Today, we're diving deep into some of the biggest lies and conspiracies about space. You might think you know the basics, but I promise, some of these truths will blow your mind. So, buckle up, because we're about to go on a cosmic journey to debunk some serious myths. First up, let's talk about our very own star, the Sun. What color is it? If you said yellow, orange, or red, you're not alone, but you're technically wrong. We see it that way because of Earth's atmosphere. When sunlight travels through the air, shorter wavelengths like blue and violet get scattered away. This is why our sky looks blue. What's left for our eyes to see are the longer wavelengths, which appear yellow or reddish, especially during sunrise and sunset, when the light passes through even more atmosphere. But what color is the Sun really? If you were floating in space, looking directly at it with proper eye protection, of course, you'd see that the Sun is a brilliant, pure white. That's because it's emitting light across the entire visible spectrum. All those colors, red, orange, yellow, green, blue, indigo, and violet combine to create white light. In fact, the Sun's peak emission, the wavelength that pumps out the most, is actually in the green part of the spectrum. So, next time you draw the Sun, maybe grab a white crayon instead of a yellow one. Now, let's tackle a really big one, the flat Earth theory. This is a topic that gets a lot of attention online, and one of the central arguments involves the Sun's path. Proponents of this model often suggest the Sun and Moon are small lights circling above a flat, disc-shaped Earth. So, let's entertain this idea for a moment and see where it leads us. If the Sun were a small spotlight circling above a flat plane, what would that look like? Well, for starters, the day-night cycle would be completely chaotic. Instead of a smooth transition from sunrise to sunset, the Sun would appear in the sky, get brighter as it neared your location, and then dim as it moved away. There would be no true night, just a perpetual twilight for most of the world. Everyone on the flat disk would see the Sun at the same time, just at different angles and brightness levels. This completely erases the concept of time zones. It has 3 p.m. in London and 10 a.m. in New York because the Earth is a rotating sphere. On a flat Earth, it would just be daytime everywhere, all at once. Furthermore, think about the seasons. We have seasons because the Earth is tilted on its axis as it orbits the Sun. This tilt means different parts of the globe receive more direct sunlight at different times of the year. A flat Earth with a circling Sun has no mechanism to explain why it's summer in Australia while it's winter in Canada. The Sun's path would have to change its circle size and speed dramatically throughout the year in a way that just doesn't align with any observable physics. The elegant, predictable model of a tilted, rotating sphere explains all of this perfectly. But let's take the flat Earth model to its most extreme and logical conclusion. What if the Sun wasn't a small spotlight, but the massive star we know it to be, somehow orbiting a flat Earth? The sheer gravitational force and energy output would be catastrophic. If it were close enough to orbit above us, its gravity would tear the planet apart. Its intense heat and radiation would literally burn the surface to a crisp. The oceans would boil away in an instant. The fact that we have a stable climate, liquid water, and a protective atmosphere is powerful evidence that we are at a safe, stable distance from our star, in a predictable orbit, on a spherical planet. Speaking of radiation, this is another topic often surrounded by misinformation, especially in discussions about space travel and the moon landings. The claim is often made that astronauts couldn't have survived the trip to the moon because they would have been fried by radiation in the Van Allen belts. While space radiation is a very real and serious danger, this argument oversimplifies the situation. First, what are the Van Allen belts? They are two donut-shaped zones of energetic charged particles held in place by Earth's magnetic field. Yes, passing through them exposes you to higher levels of radiation. However, NASA was obviously aware of this. The Apollo missions were planned to fly through the belts very quickly and through the sections where the radiation was least intense. The total time spent in the most dangerous parts was just a couple of hours. The spacecraft itself provided significant shielding. The metal hull of the Apollo command module was designed to block a large portion of this radiation. Think of it like a lead vest at the dentist's office, but for a spaceship. The dose the astronauts received was well within safe limits for short-term exposure, about the same as some medical imaging procedures. It was a calculated risk, but one that was thoroughly understood and mitigated. Interestingly, there's a region on Earth where space radiation is a bigger concern than anywhere else. It's called the South Atlantic Anomaly. This is an area where the Earth's inner Van Allen radiation belt dips closest to the surface, stretching from South America to Africa. The magnetic field is weaker here, allowing more charged particles to get through. This anomaly doesn't pose a threat to us on the ground, as the atmosphere still protects us. But for satellites and spacecraft in low Earth orbit, it's a different story. When the International Space Station or the Hubble Space Telescope pass through the South Atlantic Anomaly, they experience a much higher flux of radiation. This can interfere with their electronics, causing glitches or bit flips in their computer systems. Astronauts on the ISS have even reported seeing strange flashes of light in their eyes when passing through this region, which is caused by cosmic rays hitting their retinas. So, the danger of space radiation is very real, but it's a complex and manageable problem, not an insurmountable barrier that would make space travel impossible. So, to wrap it all up, the sun is white, not yellow. The predictable cycles of day, night, and seasons only work on a spherical Earth, and while space radiation is a serious hazard, it was a challenge that was overcome with clever engineering and mission planning. Not a cosmic force field preventing us from exploring the cosmos. The universe is far more fascinating and complex than any conspiracy theory could ever suggest. By looking at the actual evidence and applying critical thinking, we can separate scientific fact from fiction. Thank you so much for joining me on this debunking journey today. What other space myths do you want to see tackled? Let me know in the comments below. If you enjoyed this video and learned something new, please hit that like button. And don't forget to subscribe and turn on notifications so you won't miss our next adventure into the cosmos. Stay curious, and I'll see you in the next one.